Hi, welcome back to our second video on 2.6, combinations of transformations. So in this video, I want to show you how you can use a point mapping formula to quickly apply many different transformations to a base function. So we do this in order to get the graph, which is kind of really what everything is coming down to. So can you see an equation and then can you get the graph? And the answer to this is going to be yes, because it's actually really simple, this whole process. So I've made a general rule. So it says here, to graph transformed functions, one can simply apply the transformations to the ordered pairs of the base function. So this is the general rule. So you take your ordered pairs from the base function, and then they're going to map over to these new set of points. Okay, that's why I call this a mapping formula. So in order to use this, we just need to be able to pull out K, D, A, and C from our equation. Okay. So notice the way how this is set up. Whenever we have a value of K in the equation, we always want to divide X by K. And you can always go back to our general rules here from that first page. You can see that I'm just kind of combining all of these together into one. So we can see X is divided by K. Sometimes we add D if there's a horizontal shift. And my Y values, I have to multiply by A to do the vertical stretch. And then sometimes we add C if there's a shift. So putting this all together, we get this nice, pretty looking formula here. Okay, so we're going to go ahead. We're going to do this for one example. Let's just scratch this part out right here. Don't worry about this. Okay, in fact, I'll probably have it. I'll probably have it deleted when you go actually print out your document. So let's kind of get right to this. So we want to graph the following transformed function. So here's my equation. Okay, there's a lot going on here. So first, let's identify the base. We always need to do that. So the base is going to be y equals x squared. That's my base function. Okay, and I'm going to put that in over here. We're going to put in our ordered pairs for this, x and y. Notice I always use the same points. I have a couple negative ones, a couple positive ones. Okay, negative 2 squared is 4, negative 1 squared is 1. You guys get the idea. You guys have seen these points many, many times. Let's go ahead. Let's just plot them real quickly. Okay, so we're going to shift this over just a bit. My y-axis and my x-axis. Okay, here's my base points. 0, 0, then I got my ones, and then you guys know the step pattern, then it goes up 3 after from each one. Okay, so that's my base function. Now to get my new function, I want to map over the points using this form here. So let's identify A, K, D, and C. So I can see here, I'll keep everything color coded like I've done so far. So I can see that A is 2 from right here. I can see that K is negative a half. And I can see that D is 3. And I always make sure that K is factored outside of this bracket here. Okay. So we basically always need 2 sets of brackets. So yeah, D is 3 and C is 1. So I'm going to plug those into this. So my X values are going to become X over K. K is negative a half. And then I got to add the D value. So then I got to add 3. Oops. Okay, and then my Y values, we have to multiply them by A. Okay, I'm just following the formula up here, and then I got to add C. C is in orange. C is going to be 1. Actually, I should, instead of writing A here, I should put the value 2 in. Put the value 2 in. Okay, so you can see these line up exactly, right, with my parameters. That was the C value. Okay, so we can just plug these in. Take all my X values, plug them into X here, do our calculations. So some of these aren't going to be fun, but they will work. So I'm going to do all of this in red, the whole thing, and then I'll do the graph in red. So negative 2 divided by negative a half plus 3. So negative 2 divided by negative a half is actually positive 4. 4 plus 3 is 7. So negative 2 turns into positive 7. Okay, negative 1 divided by negative a half, that gives me positive 2. When I add 3, I get 5. Okay, 0 divided by negative a half, well, that's just 0. Add 3, and I get 3. Plug in positive 1. Positive 1 divided by negative a half, that's negative 2. Negative 2 plus 3 is 1. And then plug in 2. 2 divided by negative a half. It's negative a half. It's going to give me negative 4. Negative 4 plus 3 is negative 1. Okay. I can see a nice pattern to these. They're all going down by 2. So that kind of shows me that that I didn't make any mistakes. So if all of a sudden you see one of these really different, you might want to just double check what's going on. Now for the y values, take all of these, plug them into y. So 2 times 4 plus 1, that's 8 and 1, that's going to be 9. Plug in 1. So 2 plus 1 is 3. Plug in 0. 0 plus 1 is 1. Plug in 1. 2 and 1 is 3 again. And then the next one's going to give us 9 again. 2 times 4 plus 1, that's 8 and 1, that's 9. Okay. I always, because I know this is an x squared graph, the base is x squared, I know my final values are going to show symmetry for a parabola as well too. So I keep that in mind when I'm doing calculations as well. Okay, let's go ahead and plot. So 7, 9, 7 is all the way. There's 2, 4, 6, 7. 7 is going to be here. So that was there. And all the way up 9. So 2, 4, 6, 8, 9. So that's right here. Then we have 5, 3. So that's 5 is over here. And I got to go up 3. It's right there. And then I have 3, 1. 3, 1 is right here. That's my vertex. And then I have 1, 3. That's that point there. And then I have negative 1, 9 right up here. Okay, so you can see I have the nice shape for my quadratic. So this would be, just to label this one, it would be y equals 2 times negative a half, x minus 3, close up the bracket, squared plus 1. That's my equation. So 4 transformations done in order to get that red curve. Okay, now that's a lot easier than trying to do 4 separate transformations in order to get the red final graph. Okay, let's just get this one started. So we're not going to graph this one. We're just going to go ahead and state the transformation. So it says, how would the order pairs for y equals negative 2 over x minus 3 minus 1 be obtained if the base function is 1 over x? So if the base function is 1 over x, then I can see that a few things have been done to it. Okay. So I can tell that this is my a value up here. I'm going to color code this. So we'll go, this is my a value up top. Okay, let's actually just draw an arrow. That's a. Okay, k is always here. I'm just going to put a 1 there. That's always where k goes. So we don't have anything there, so I'm not going to worry about k for this one. But I can see d is 3. Okay, d is going to be 3. And I can see c is always added at the end. So remember, a and c are done outside of the function. Okay, and k and d are always done inside the function. So one way, like if you're really having a hard time kind of looking at this one, you could look at it like this. You could say we have a times 1 over k x minus d plus c. And you can see, okay, k and d are always inside the function, so they're in the bottom with x, right? And then a and c are done afterwards outside. So the reason why I knew that a was -2 is because I know they just multiply it in when they have it in this form. So these equations are kind of always given in this form. So basically what we can conclude from this, if you just multiply that in, we're always going to have the form a over k x minus d plus c. Okay, so this is a great way to look at these rational functions and get a, k, d, and c. So I'm just going to put a equals -2. So this is really good. I can use the point mapping formula. And you might say, well, Mr. A, what about k? There's nothing there. So that's fine. I just skip it. Okay, so I'm just going to write out the formula for now. So if one of them isn't there, I just leave them out. That's all. So I know that xy is going to map over to x plus 3, comma, a is -2, so I'll have -2y, and c is -1, so -1. So this shows my horizontal shift, right 3, vertical stretch at -2, shift down 1 unit. Okay, so using this formula, I could then get all my new points. Now, I don't really like doing transformations for this kind of function, the 1 over x, just because you have to end up working with fractions. So, but usually if you're ever given kind of one of these like homework or on a test, we're not going to load it up with a bunch of transformations. It'll usually just be 1 or 2. It's usually like the parabolas that will kind of get kind of juicy in a sense. There will be a lot of transformations happening to them because they're a little bit easier to come up with the points. Okay, that's it for this video. I will see you in the next one.